Today we're doing section 3.5, slopes of lines. So please take out something to take notes on, and as usual, complete the check it out questions, and then write down any questions and bring them to class after you reviewed the lesson.
All right, we have two learning targets today. First, I can find the slope of a line. Second, I can use slopes to identify parallel and perpendicular lines.
Okay, so here's 3 vocabulary words, and the next slide will actually show them on a coordinate plane, but rise, run, and slope. And Miss Briscoe will tell you some more.
All right, so as it says, the rise is the difference in the y values of 2 points. So if we look at our line here, and we've got 2 points here, one here and one here, the y value for the first point, or y1, is 1. The y value for the second point, or y2, is 7. The difference between 7 and 1 is 6, so we have a rise of 6.
So rise is going to be our vertical distance.
Correct. Rise is the vertical change. The run, oops, let me check that off there. So that's the rise. So the run is the difference in the x coordinates of 2 points. So here you can see for this first point, our x1 is 2. That's our horizontal. That's our horizontal coordinate of that point. And then x2 here for this point is going to be 5. So the difference between 1, sorry, that's 1, not 2, 1 and 5 is going to be 4. So we have a run of 4 here.
So again, our run's going to be our horizontal distance.
Horizontal distance or horizontal change. So what is the slope? Well, the slope is going to be the rise over the run. So basically, you probably want to write this down in your notes. The formula for slope is y2 minus y1 over x2 minus x1. It's just the vertical change over the horizontal change.
What does the m stand for in that equation? We haven't seen that before, have we?
M is how we denote slope in most of our math books. So from now on out, you will see your slope marked as M. Good question.
Thank you. So now we have an example. We want to use a slope formula to determine the slope of each line. So for line AB, first of all, you notice line AB is a horizontal line. So slope of a horizontal line, does it have any vertical difference? It doesn't change at all, so therefore, it's going to be our change in y, or slope. Okay, so the slope for line AB, A is at -2 for x, and B is at 3. And our y never changed, so our equation becomes 0 over 5, 0 divided by 5, which is 0. 0 divided by any number is 0. We just can't divide a number by 0. That's undefined. So horizontal lines are always going to have a slope of 0. Our next problem is finding the slope of line AD. Okay, and as I said, slope for AD now, we went up 6, but we didn't run any, so our run was 0. So a number divided by 0 is going to be undefined. So a vertical line has an undefined slope. Keep those two slopes in mind. For horizontal line, slope is 0. A vertical line, the slope is undefined. Our next problem, find the slope of line AC. So for the slope of line AC, we have point A up here, point C is here. So looking at this, we start at A, we go down, we rose -5, so we put -5 here in the numerator, but then we ran a +6, so it's a negative line, slope is -5 over 6. Okay, so for our last problem, slope of line DC, point D is here, point C is here, so we rose 1, so 1 was our numerator, and we ran 6, so our slope becomes 1 over 6. They'll have to use a slope.
All right, this is your check it out problem. So you should use the slope formula. Notice it's not in the coordinate plane, so you should use your y2 minus y1 over x2 minus x1 to calculate this.
So as you're calculating the slope of a line, this chart here is a nice way to remember if you've calculated it correctly. If you end up with a positive slope means that the line is going to be rising, going left to right, it's going up. A negative slope is falling, it's decreasing, going down as it goes left to right. A zero slope is going to be a horizontal line, a slope of 0. And then our undefined slope, as we said in the last slide, was our vertical line is an undefined slope. So if you have a horizontal line, it should be slope 0. All vertical lines will have an undefined slope. God, I know.
All right, let's look at a practical example of slope. Justin is driving from home to his college dorm. At 4 p.m. he's 260 miles from home. At 7 p.m. he is 455 miles. So obviously going to college away from home. Graph the line that represents Justin's distance from home at a given time and find and interpret the slope of the line. So here's our graph, it's already drawn for us, and here's our line. So what do we have here on our x-axis? This is hours. So this is 4 p.m. when he started, and then we have 7 p.m. is the next point in time. This is our distance. So we were at 260 miles at 4 p.m. So this is 260, and at 7 p.m. we're 455 miles. So that's our plot. Those are our points. We want to find the slope. We're going to use our slope formula to calculate the slope using those 2 points.
You know what you just did? Look what you just did. You're still going.
All right, I hope you enjoy the colorful solution to this problem. So the 2 points are noted here. This is 1. This is our first point. This is our second. I always like to mark x1, y1, x2, y2. So when I plug them into the formula, I don't get things mixed up. So here is our slope formula. Then I just plug the y2, y1, x2, x1 into the formula. And I end up with 185 over 3. And my final answer is 65. What does that mean? It means that Justin is going 65 miles an hour.
And now it's your turn to interpret a graph. Use a graph below to estimate how far he will travel. So you've got the plots, you got the lines plotted on there. And figure out his average speed.
All right, we have 2 more theorems about parallel and perpendicular lines. The first one, parallel lines theorem, appropriately named. In a coordinate plane, 2 non-vertical lines are parallel if and only if, remember this biconditional term, they have the same slope. Any 2 vertical lines are parallel. So if the slopes are the same, then the lines have to be parallel. Vertical lines are always parallel. Remember, the slopes are undefined. So you just have to know if they're vertical, they're going to be parallel. Perpendicular line theorem tells us in a coordinate plane, 2 non-vertical lines are perpendicular if and only if, are biconditional, the product of their slopes is -1. Vertical and horizontal lines are perpendicular. So vertical and horizontal lines are perpendicular. Again, you can't calculate slopes of vertical lines. Slope is -1. The product of their slopes is -1. Basically, that means the slopes are opposite or negative reciprocals of each other.
Yep. So as Ms. Briscoe mentioned, we talked opposite reciprocals. That means if a line has a slope of A over B, then the slope of the line perpendicular is going to be the opposite reciprocal, which would be negative A over B. And so it's a ratio. So to take the product, if we multiply A over B by negative B over A, we'll get a -1. And those are opposite reciprocals.
All right, this example says graph each pair of lines, use their slopes to determine whether they are parallel or perpendicular or neither. So UV, so we're going to use the points, these are our 2 endpoints for UV. And then our 2 endpoints for XY are here and here. That's a good point to make. All right, so I've drawn my lines UV and XY. All right, so now I really have drawn the two lines the way they're supposed to be drawn. UV and XY. So I'm calculating the slopes again. I always label them so that I can plug them into the formula and calculate correctly. So if I have my x1, y1, x2, y2 for UV, I'm going to get -1 minus 2, -1 minus 0, and that's going to give me a -3 over -1. Remember, in math, two negatives do make a positive, so we end up with a +3 slope. For xy, I have my x1, y1, x2, y2. That's going to give me 3 minus 1 over -3 minus 3, which gives me a -2 over 6. For 2 over -6 just means that the fraction as a whole is negative, which reduces to be a -1/3. So what does that tell us about the two lines? Well, I multiplied the slopes of the two. 3 is the slope of the first line, -1/3 is the slope of the second. When I multiply them together, I get a -1. Therefore, UV and XY have to be perpendicular.
Okay, here's another example to determine whether the parallel lines are parallel, perpendicular, or neither. So we have line GH, and G is at the point, G is at -3, 2. So -3, -2, G is there. H is at the point 1, 2. That's going to be our H. And then we'll plot the points for I. I is at -2, 4. And J is at 2, -4. So calculate, after we plot our lines, our points there, calculating the slope. The slope for GH, we get 2 minus a -2 over 1 minus a -3. Simplifies to give us 1. And our slope for IJ, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, simplifies to give us a -2. We can look at these slopes and realize they're not the same, so therefore they're not parallel. They're not opposite reciprocals either. So what's our other choice then, Ms. Briscoe?
They must be neither.
Yeah, these are going to be neither.
All right, another example. Graph each pair of lines, use their slopes to determine whether they're parallel, perpendicular, or neither. So let's look. We have, whoops, not that. We have C and D, and E and F. So we'll plot the points, calculate the slopes, and figure out whether they're parallel, perpendicular, or neither. Okay, so I plotted my points, EF and CD. When I calculate the slopes using my x1, y1, x2, y2, slope of CD is going to be 2 when we simplify it. The slope of EF will simplify to 2. Since the slopes are equal, CD have to be parallel.
And it's nice that your graph actually shows those two lines. So we plot the points correctly and the graph supports.
They look
answers,
parallel.
yeah.
Yes, that's amazing.
Can we tell by just looking at the graph if the parallel or not, or do we have to actually figure out the slopes?
No, because if one of the coordinates instead of being 1 was 0.9, so for instance here, then it might look very parallel, but it would not be. So you really have to use the slope formula. Good question.
Do the calculation still. Okay. And now it's your turn. You will have 3 check-it-outs to do to determine if the lines are parallel, perpendicular, or neither. Write them down, bring any questions.
And so that ends our lesson. Here's our summary for slopes of lines. Remember, slope is rise over run, which is your vertical change over your horizontal change. The slope of parallel lines are equal, and slope of perpendicular lines are opposite reciprocals. We'll see you next class.